fundamental principle in electrical wiring is maintaining distinct grounding systems. The equipment grounding system serves as the primary safety net, providing a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. An isolated ground, on the other hand, is a specialized grounding technique employed to minimize electrical noise and interference in sensitive electronic equipment. Mixing these two grounding systems can compromise safety and create operational problems. In a standard electrical panel, the equipment grounding bus is directly bonded to the metal enclosure of the panel and ultimately connected to the main grounding electrode system of the building. This provides a direct path for fault currents to flow back to the source, tripping the breaker and energizing the circuit in the event of a ground fault. Branch circuits feeding non-isolated ground receptacles must be connected to this equipment grounding bus. Connecting these circuits to an isolated ground bus introduces several potential problems. Firstly, the isolated ground bus is not intended to carry significant fault current. It is typically connected to the main grounding system through a single point connection, often using a relatively small conductor. This connection may not be able to handle the high fault currents that can occur during a ground fault, potentially leading to overheating and failure of the isolated ground conductor. Secondly, using the isolated ground bus for non-isolated ground receptacles can create a parallel ground path. This means that fault current can flow through both the equipment grounding system and the isolated grounding system. This parallel path can reduce the effectiveness of the equipment grounding system, potentially delaying the operation of overcurrent protective devices and increasing the risk of electrical shock. Thirdly, the isolated ground system is designed to minimize electrical noise. By connecting non-isolated ground receptacles to the isolated ground bus, you are introducing a source of noise into the system, which can degrade the performance of sensitive electronic equipment. It is crucial to understand the purpose and limitations of an isolated ground system. It is intended for specific applications where a clean, noise-free ground is required. These applications typically involve sensitive electronic equipment such as audio equipment, medical equipment, and computer systems. In these applications, the isolated ground bus is connected to a dedicated grounding electrode system that is separate from the main grounding electrode system. This helps to minimize the amount of noise that is coupled into the ground system. When using an isolated ground system, it is important to follow all applicable electrical codes and standards. The National Electrical Code, or NEC, provides detailed requirements for the installation and use of isolated ground systems. These requirements are designed to ensure the safety of personnel and equipment. For example, the NEC requires that the isolated ground conductor be insulated and that it be run separately from the equipment grounding conductor. The NEC also requires that the isolated ground conductor be connected to the grounding electrode system at a single point. This helps to prevent ground loops and minimize noise. In the situation at hand, the fact that the existing power panel is full does not justify the use of the isolated ground panel for non-isolated ground receptacles. The proper solution is to install an additional standard power panel to accommodate the additional circuits. This will ensure that the equipment grounding system is properly maintained and that the risk of electrical shock is minimized. Installing an additional panel is a straightforward process that involves connecting the panel to the main electrical service and running branch circuits from the panel to the receptacles. It is important to follow all applicable electrical codes and standards when installing an additional panel. Several alternatives exist to address the lack of space in the original power panel. Firstly, consider subpanels. A subpanel is a smaller panel fed from the main panel. This allows you to extend your circuit capacity without replacing the main panel. Secondly, tandem breakers can be used. These breakers allow two circuits to be placed in a single panel space. However, check that the panel is rated for tandem breakers before using them. Thirdly, consolidate circuits. Evaluate existing circuits to see if any can be combined or removed. This may free up space for new circuits. All work should be done by a qualified electrician to ensure compliance with electrical codes and safe practices. Improper wiring can create fire hazards and electrical shock risks. The NEC addresses the proper grounding and bonding techniques in Article 250. Specifically, Article 250.146 covers the connection of the equipment grounding conductor to the grounding electrode system. This section emphasizes the importance of a low impedance path for fault currents. Article 250.96 discusses the bonding of metal enclosures and other non-current carrying metal parts. This bonding is essential for providing a safe path for fault currents and preventing electrical shock. When dealing with sensitive electronic equipment, Article 647 provides specific requirements for sensitive electronic equipment grounding. This article addresses the use of isolated ground systems and other techniques for minimizing electrical noise. In summary, connecting non-isolated ground receptacles to an isolated ground bus is a safety hazard and a violation of electrical codes. The equipment grounding system and the isolated grounding system must be kept separate to ensure the safety of personnel and equipment. If additional circuit capacity is needed, install an additional standard power panel or explore other alternatives such as subpanels or tandem breakers. Always consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable codes and standards. Grounding and bonding are critical aspects of electrical safety. Understanding the principles and requirements of grounding and bonding is essential for anyone who works with electricity. By following the proper procedures, you can help to prevent electrical shock and fire hazards. Remember, the purpose of grounding is to provide a low impedance path for fault current to return to the source, causing the overcurrent device to operate. The isolated ground is designed to reduce electrical noise in sensitive equipment, but it's not intended to handle fault current like an equipment ground. Connecting standard receptacles to an isolated ground creates a safety risk, as the path to ground is not as robust as it needs to be and can cause harm. Furthermore, it can compromise the noise reduction benefits of the isolated ground. It is always better to install another standard power panel rather than using the isolated ground panel for standard receptacles. This ensures that the electrical system is safe and in compliance with code. Always prioritize safety when working with electricity. It's important to consult with a qualified electrician, adhere to electrical codes, and use appropriate grounding techniques to prevent electrical hazards. Grounding is a critical safety measure in electrical systems, serving to protect people and equipment from dangerous electrical shocks and damage. The equipment grounding system and the isolated ground system serve distinct purposes. Understanding the differences between these systems is essential for ensuring safety and optimal performance of electrical equipment. The equipment grounding system is designed to provide a low impedance path for fault currents to flow back to the source. This path allows the overcurrent protection devices, such as circuit breakers or fuses, to quickly trip and energize the circuit in the event of a ground fault. This rapid de-energization minimizes the risk of electrical shock and prevents damage to equipment. The equipment grounding system typically consists of the following components. Firstly, the grounding electrode system, which includes grounding rods, grounding plates, or metal underground water pipes that are in direct contact with the earth for 10 feet or more. Secondly, the equipment grounding conductors, which are the wires that connect the metal enclosures of electrical equipment to the grounding electrode system. Thirdly, the bonding jumpers, which are used to connect metal parts of the electrical system together to ensure a continuous grounding path. The isolated ground system is a specialized grounding technique used to minimize electrical noise and interference in sensitive electronic equipment. The electrical noise can disrupt the operation of electronic equipment and cause inaccurate readings or malfunctions. The isolated ground system helps to reduce noise by providing a separate grounding path for sensitive equipment. The isolated ground system typically consists of the following components. Firstly, an isolated ground receptacle, which is a special type of receptacle that has a separate grounding terminal that is not connected to the metal enclosure of the receptacle. Secondly, an isolated ground conductor, which is a wire that connects the isolated ground terminal of the receptacle to a dedicated grounding electrode system. Thirdly, a single-point connection to the main grounding system, which is used to prevent ground loops. Ground loops occur when there are multiple paths for ground current to flow, which can create noise and interference. Mixing the equipment grounding system and the isolated ground system can compromise safety and create operational problems. Connecting non-isolated ground receptacles to an isolated ground bus introduces several potential problems, including firstly, reduced fault current capacity. The isolated ground bus is not intended to carry significant fault current. Connecting non-isolated ground receptacles to the isolated ground bus can overload the isolated ground conductor and potentially cause it to overheat or fail. Secondly, increased risk of electrical shock. If a ground fault occurs in a non-isolated ground receptacle connected to the isolated ground bus, the fault current may not be able to flow back to the source quickly enough to trip the circuit breaker. This can increase the risk of electrical shock. Thirdly, compromised noise reduction. Connecting non-isolated ground receptacles to the isolated ground bus can introduce noise into the isolated ground system and degrade the performance of sensitive electronic equipment. When additional circuit capacity is needed, it is important to install an additional standard power panel or explore other alternatives such as subpanels or tandem breakers. Installing an additional standard power panel ensures that the equipment grounding system is properly maintained and that the risk of electrical shock is minimized. Subpanels can be used to extend the circuit capacity of an existing panel without replacing the entire panel. Tandem breakers can be used to install two circuits in a single panel space, but it is important to ensure that the panel is rated for tandem breakers before using them. Always consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable codes and standards. Electrical codes and standards are designed to ensure the safety of personnel and equipment. It is important to follow these codes and standards when performing any electrical work. Grounding and bonding are critical aspects of electrical safety. Understanding the principles and requirements of grounding and bonding is essential for anyone who works with electricity. By following the proper procedures, you can help to prevent electrical shock and fire hazards. Electrical safety is paramount. Always prioritize safety when working with electricity. It's important to consult with a qualified electrician, adhere to electrical codes, and use appropriate grounding techniques to prevent electrical hazards. Electrical installations must adhere to the National Electrical Code, or NEC, which provides comprehensive guidelines for safe and effective electrical systems. The NEC covers all aspects of electrical wiring, grounding, and equipment installation. Proper grounding and bonding are essential for electrical safety, providing a low impedance path for fault currents to return to the source and ensuring the reliable operation of overcurrent protection devices. The equipment grounding system and the isolated ground system serve distinct purposes and should not be mixed. The equipment grounding system is designed to protect people and equipment from electrical shock, while the isolated ground system is intended to minimize electrical noise in sensitive electronic equipment. Connecting non-isolated ground receptacles to an isolated ground bus can compromise safety and degrade the performance of sensitive electronic equipment. When additional circuit capacity is needed, it is important to install an additional standard power panel or explore other alternatives such as subpanels or tandem breakers. Always consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable codes and standards. Understanding the purpose and limitations of an isolated ground system is crucial for ensuring its proper application. The isolated ground system is not a substitute for the equipment grounding system and should not be used to ground non-isolated equipment. The proper use of an isolated ground system can significantly improve the performance of sensitive electronic equipment, while the improper use can create safety hazards and operational problems. The NEC provides detailed requirements for the installation and use of isolated ground systems. These requirements are designed to ensure the safety of personnel and equipment and to minimize electrical noise. It is important to follow these requirements carefully when installing or modifying an isolated ground system. Electrical work should only be performed by qualified electricians who are familiar with the NEC and other applicable codes and standards. Improper electrical work can create safety hazards and lead to serious injury or death. Always prioritize safety when working with electricity. Consult with a qualified electrician, adhere to electrical codes, and use appropriate grounding techniques to prevent electrical hazards.